Hi guys, welcome back to the channel. My name is Jag, and again, for those of you who are new, I wanted to welcome you to my channel. This channel is all about math and chemistry, science, okay, that which includes also biology at the high school level as well as the elementary level. So with that, let's get started. Today's class is going to be us continuing with our Chemistry 11 content. What we're going to look at is basically this topic of empirical formula, all right, and how to calculate it. So let's take a look at this example, okay, from the textbook. One more time, I'm going to just like read the question out loud, and we're going to write down what's given from the question on the board, okay? So it says calculate the empirical formula of a compound that is 85.6% carbon. So I'm going to write down the percentage of carbon, okay, that's given here, and it's 14.4% hydrogen. Okay, so we're writing down the percentage, okay, and what you're going to do when you calculate the empirical formula is I am assuming 100 grams. Okay, so I'm going to write that on the side. So let's assume 100 grams, okay, which basically means I have 85.6 grams of carbon, okay. I have 14.4 grams of hydrogen, okay. What we're going to do now is we're looking for the number of moles, okay, for carbon and for hydrogen. So I'm going to put small n here, okay. So remember again, the moles is equal to the mass divided by the molar mass. So check your periodic table for the molar mass for carbon, which is 12. Okay, I'm going to take my calculator here. I'm doing 85.6, okay, divided by 12. And it's 7.13. The 3 is repeated here, okay, so let us just round that. And this is in moles. Again, I like to keep about 4 decimal places when I'm rounding for the moles, and that's just to make sure my answer is very accurate at the end, okay? The same thing here for hydrogen. Again, when you are using the mass from the periodic table, I can just round that, okay? It won't cause a significant difference in your answer. Okay, I'm going to do again for hydrogen, the mass divided by the molar mass, which is 1, okay, or it's 1.01. And this is going to stay the same, so 14.4 moles, okay, of hydrogen, all right? So this is kind of like the first step here, so let's write like 1, okay? And in the second step, okay, what we're going to do is I'm looking at both of the moles. I'm going to divide both of these moles by the smallest number of moles, okay? So if you look at 7.13 and 14.4, okay, I see that the 7.13 is basically smaller. So I'm going to divide by that. And the same thing for the hydrogen. I'm going to do divided by 7.13, with the 3 is just repeating here, okay? So I notice, okay, for the carbon, okay, I'm getting 1. So I'm going to put 14.4 divided by 7.1333, okay, so 3 times. Okay, and I'm getting an exact value of 2.0, okay? So I'm just going to round that to 2, all right? Again, when you are rounding, okay, for the number of moles here, when I'm doing the lowest ratio, and that's what the empirical formula is. It's basically the lowest ratio of each of the elements here, and that's how I know it's the empirical formula of the compound, all right? And so because I have carbon as 1, so let's put therefore with our 3 dots like this. Okay, so it's like this. The carbon is 1, like 1 atom of carbon. Okay, there are 2 atoms for hydrogen. Okay, and again, I don't need to write 1. Okay, I can just leave it like this. So I'm going to write CH2. Okay, and basically this is the final formula. Okay, it is CH2. This is the empirical formula. I'm just going to box it. And you notice, okay, like in math, I can't actually reduce this formula, okay? And that's how I know that this is the empirical formula. Okay, and just to show you as an example, say the formula was C2H4, okay? I can see that basically these are some even numbers. I can divide each of these numbers by 2 to reduce it. So this would not be an empirical formula of the compound. Okay, does everyone understand that? All right, so that looks good. Okay, with that, we're gonna try basically one more example here. And the reason we're trying this example, okay, is I want to show you the empirical formula. And when you divide it here, it's not going to give you a whole number. Okay, so we're gonna see what we need to do in this case. Okay, so with that, I'm going to take off this compound, an example, okay? And again, for this example as well that we're going to do, the steps are going to be exactly the same, okay? I'm going to read out the question and we'll write down basically what's given on the board, okay? So the percentage composition of a fuel, it doesn't tell you what fuel it is 81.7% carbon. Okay, so let's write that here, 81.7%. Okay, this is carbon. It's 18.3% for hydrogen. Okay, so this is for hydrogen, all right? Again, I'm assuming 100 grams. So we're gonna find the number of moles. Let's put 1. This is the first step here. It's always, the steps are always going to be the same, okay? So make sure you just do like a lot of practice questions from the textbook, okay? And that way you don't even really need to memorize the steps here, all right? So we're gonna do 81, okay? So 81.7 grams. Again, I'm going to divide that by 12, okay? So keep your calculator handy, okay? In this unit for chemistry, there are just a lot of different calculations I have to do. So I'm getting 6.808, okay, is the moles for carbon. And I'm going to do the same thing for hydrogen. So 18.3 divided by 1, which stays the same for hydrogen. Okay, hydrogen is actually a very simple element, okay? So it's easy to do the calculations for it, all right? I notice in this example also, this compound contains carbon and hydrogen. Again, this does not have to be the case, okay? You'll do a lot of examples where you have different compounds, okay? Oxygen and nitrogen are very common elements, okay, that are found in these compounds. Okay, so with that, we're gonna go to the next step here. All right, and in the second step, okay, again, I'm looking at both of the moles that I have. I'm going to divide it by the smallest number of moles, okay? I have 6.808 and 18.3. So I can see that the 6.808 is my lower number. Okay, and I'm going to divide the carbon, the moles of carbon here, by that number. And I'm also going to divide the moles of hydrogen, okay, by the same number. So this is just equal to 1, we see that, okay? On the other side, I'm going to do 18.3 divided by 6.808, okay? And I'm going to write down the number I'm getting here. I'm getting 2.688, okay? Now, if I look at this number basically, okay, I cannot round this to 3, okay? That's probably what everyone is thinking. Let's just round it to 3 and move on with our day, okay? However, if you get like a number here, when I divide by the smallest number of moles, and it's not an exact number, so if it's like 2.5 or 2.6, I cannot round this to 3, okay? What you're going to do is I'm going to take each of these numbers. We're gonna first try multiplying it by 2. So I'll write it over here so everyone can see it. Okay, so I'm gonna put times 2. So say I take 2.688 times 2 here, and I'm getting 5. Let's just do 2 decimals, 38, okay? And on this side, I'm getting 2. So it doesn't really matter what carbon is here, okay? However, even when I multiply this by 2, I notice 5.38 is not an exact number here. I cannot round this to 3 even, okay? So when you're doing the smallest number of moles for the empirical formula, it does have to be basically an exact number, okay? So let's take this off then. So I know I can see that I can times this by 2, okay? It's not giving me an exact number for the number of atoms. So we're gonna try and multiply this by 3. Okay, so again, the carbon doesn't matter. Carbon is just 3, so that's a whole number. I'm gonna do 2.688 and times that by 3, okay? And I am getting 8.06, okay? So does everyone see that? Okay? it's giving me an exact value of 8 or 8.0. Okay, I want to make sure I can round that. I can round that to like 1 decimal place, okay? And that is enough. So I could even be like, this is 8.06 or like 8.1. It has to be really close to the whole number, okay, in order for you to round it. Okay, so we're going to use the 3 here, all right? And I'm going to put the therefore statement, okay? So therefore, I have basically 3 atoms for carbon. So I'm going to put C3, okay? And there are 8 atoms for hydrogen. Okay, let's box our answer here, okay? So this is actually my final answer for this compound. Again, this is the empirical formula. I notice carbon is 3 and hydrogen is 8. Okay, 3 here is a prime number, and I can't actually reduce, okay, these numbers. Both of them are not even, okay? One number is odd and the other number is even, okay? So that's actually how you know that it is the empirical formula, okay? Again, I won't be able to reduce it, my answer at the very end, okay? And this is the smallest whole number ratio for each of the elements within the compound, all right? So again, if there are no questions here, that brings this video to an end. And today we covered Chemistry 11, and the topic was on the empirical formula. Again, make sure you're doing a lot of questions from the textbook so you don't get confused, okay? There can be many variations for calculating the empirical formula as we move on through the contents for Chemistry 11, okay? Some of the questions will be getting a little bit harder, okay? Just because the teacher will come up with different variations of the question, okay? Make sure you're doing a lot of these practice questions in the textbook, or you can also go online. There are a lot of online resources for chemistry, and you could just download a worksheet, try doing like the questions, and usually most of these chemistry worksheets do have also the solutions. All right, so again, thank you for watching this video. If you like the content, please make sure you're clicking on the like button below and subscribe to the channel, and I will see everyone in the next video. Thanks, bye.